Okay, so now we should be live. Okay, hello guys, once more. I had some troubles understanding how to start the stream because I mentioned in the I schedule it and I didn't click on go live. So the stream is up and running, but I was not live. So now I should be live. Okay, so what's going on? Still, I do not see it working. Okay, so now I see. Okay, good. So there are some changes on the stream quality. Looks like I've used wrong settings for my OBS Studio. So now it should be a little bit better, hopefully. Okay, so yeah, last time we did stop at this problem, find k-word of an array. So we'll be picking up from this problem. And yeah, let's see how many we'll solve during this session. So we'll continue our grind. So far we have like 106 problems solved out of 766, I think. So yeah, there is a lot of work to be done if I want to have like all the problems from LeetCode, all the easy problems from LeetCode solved. But anyway, yeah, we are going slowly, topic by topic now. So last topic which we choose, I choose, it's bit manipulation. I would like to improve my bit manipulation skills. And now I'm trying to solve a problem, and last time I didn't understand what I need to do, and today hopefully I'll manage. I'll manage to figure it out. Okay, good. Yeah, I'm not sure if the lighting is good though. Let me switch it a little bit. Yeah, probably this way will be better. Okay, so let's check what do they want from us from this problem. You're given a zero indexed integer array nums and an integer k. The k-or of nums is a non-negative integer that satisfies the following. The ith bit is set in the k-or if and only if there are at least k elements of nums in which bit I is set. Return the k-word of nums. Note that a bit I is set in x if 2 power I and x equal 2 power I, where AND is bitwise AND operator. Yeah, last time I was confused about this one, and today this did not bring any more clarity. So yeah, let's try to follow some examples and then see the constraints, and maybe we'll read through the hints, because usually hints are very helpful. So we've got the following array called nums, having the following values like 7, 12, 9, 8, 9, 15, and k4. Output should be 9. So bit 0 is set at num 0. Num 0 is 7. Nums 2. Nums 4. And nums 5. Bit 1 is set at num 0 and nums 5. What? Only bits 0 and 3 are set in at least k elements of the array. And bits I greater or equal than 4 are not set in any of the array's elements. Hence, the answer is 2 power 0 plus 2 power 3. So this should be 1 and this should be 3. Should be 8, and ending result will be 9. What? What do they want from me? Once again, yeah. The k-word of nums is a non-negative integer that satisfies the following. The ith bit is set in the k-word if and only if there are at least k elements of nums in which bit I is set. Bit I, what does it mean, ith bit? Bit I is set. Know that a bit I is set in X if 2 power I and X equal 2 power I, where AND is the bitwise operator, AND operator. Okay, so I guess we have a formula. So we have this formula like 2 power I and X will be equal to I. So what does it mean? So what's X first? I'm not sure I understood what's X. Okay. Yeah, let's try the following. I mean, probably I'll need a drawing board. And yeah, I'm not sure if I need this. I need only the screenshot and this part, and let's follow the first example. So let's go with the first example. We have it here and try to figure it out. What in the world is going on here? Yeah, I have this blink on my eye, so probably I'll close it. Cool. So we have returned the k-word of nums. Note that bit I is set in X if 2 power I and X equal 2 power I, where AND is a bitwise operator. So bit 0 is set at num 0. So we have 7. What will be 7? It will be like 0, 2 power, it's 1, 1, 1. So that will be 1. That's 7, if I'm not mistaken. So 0, 0, 0, 1, 1, 0, 1, 1, that will be 3, 1, 0, 0, 1, 2, and 1. So yeah, that should be 0. So this will be 7 in a bit form. So that's 7. Now, note that bit I is set in X if 2 power I and X but what's X? They didn't explain properly what is X. So yeah, let's check again, once again. The ith bit is set in K in the k-word if and only if there are at least k elements of nums in which bit I is set. So okay, so let's go again. So we have this one. This one would be like so this will be like 4, 2, 0. This will be 8. So 11 would be this one set, this one not set, this one set, this one set. So this will be like 11. But I need 12. Okay, so 12 will be this set, this not set. So this will be like 12 in binary form. Nums 5. Yeah, let me see. 1, 2, 3, 4, 5. So we have 15. So next one will be 16. So this should be set. 15. 15, it's everything like that. That will be like 15. So what does it mean? Bit 1, bit 0, it's set at nums 0, nums 2, nums 4, and num 5. So this is bit 0, it's set at, okay, so probably, yeah, kind of I started figuring out what's going on. So first stage, we'll need to transform every number into its binary form. So we'll have here bit 0, bit 1, not 1, this will be like 2, power 2, this will be like 4, 8, or let's put it this way, probably 0, 1, 2, 3, and 4. So this will be like the power of 2's. And now I'll put the values here to work a little bit faster. And 16. So do we need more? No, I think it's enough for the first example. So yeah, now let's go with the, each number separately. So 7. 7 will be like, so this is definition. So yeah, let's use another color for this part. So we'll have 7. 7 will be like this bit set 1, 1, 1. This will be like 7. So this will be 0, 0. Next one, 12. 12 will be 0, 1, 1, 0, 0. So yeah, probably I should mark here 7, and here I'll put 12. And probably I'll switch to some lighter color. So for 9, how do we make 9? 9 will be like 8, 1. We can do it. 8, 1, yeah. 1, 0, 0, 1. So that will be like 9. Maybe I'm mistaken a little bit, but should be fine. 8. 8, we have this one. What's else? 9 again. Yeah, we have 9, so we'll not use. 9 again. So we have 15. 15 will be everything set to 1. So 8 plus 4 plus 2 plus 1. So yeah, that would be 15. Okay, so we have the values in binary form. And now what we'll need to check, if I understand correctly, is we need to look for all bits starting at position, at k position. So if I understand correctly, I'll need to look at this position, this, and this, because we have like k4 max. So let's see the explanation. Bit 0 is set at num 0, nums 2, nums 4, and nums 5. So where do we have ones? Like here we have, here 9, 15, num 0, nums, okay, so two nines and 15. So yeah, okay, so we've got bit 0 is set here. This part we understood. Bit 1, so we will check. Probably I needed to put once again another 9 to, yeah, let me add another 9 here to remove the confusion, because this will be easier to count. So bit 1 is set at num0 and nums5. So let's check where do we have bit 1 set. So we have here and here. So yeah, that's correct. Bit 3 is set at nums1, num2, num3, num4. So num1, num2. No, bit 3 we need. Yeah. So num1, num2, num3, num4, num5. Yeah, that's correct. Only bits 0 and 3 are set in at least k elements of the array. What? Oh, so we need to find what bit is set in k elements. So if you look at this one, so yeah, bit only bit 0. Yeah, so let's check bit 0. Yeah, so bit 0 it's 1, 2, 3 and 4. So yeah, we have 4. K in our case it's 4. So that's correct. And here we have 5. Bit 1 will be 5. Okay, now it's clear. Yeah, probably I'll need to move this a little bit up. Okay, so now how do we compute the answer? So in order to compute the answer, we'll have like 2 and the power of the bit 0 and 3. Oh my god, that's actually a cool problem. I wouldn't tell that that's madness or something, but yeah, I mean, I spent some time trying to figure it out. Okay, so how can we check? So let's assume we'll define our algorithm in the following form, something like I guess first iteration we'll have it in binary form, because we'll need to understand the bits, or actually what we can do, maybe we can shift right. If we shift right one position, every time we can get the last one, which one is set. Yeah, but we'll need to count them. Okay, so yeah, shifting right, it's a nice idea. I mean, if you have like this format, so let's assume you have like a 0, in our case 0, 1, 1 and 1. If we shift it right one bit, this will become like 0, 0, 0, 1, 1. And we know the last one, so it's easier to manipulate. But how does it help us? I'm not sure yet. Not sure I figure it out. Okay, don't know, that's a good solution. What else can we do? Maybe we can create a hash map where but we'll need to figure it out how big should we make it. But probably I mean we don't really care actually, because we'll need to count how many bits are set at the end of the day. So yeah, easiest way is to do with a hash map. So we'll have the following algorithm. So we'll create our hash map here. I'll put it as a small object. We'll go each number. Each number we will check the bits, which bits are set. So I guess for the first operation, if it's 1, yeah, I mean, there are multiple ways to do it. I'm trying to figure it out a way how we can use this shifting right to get the last one. So probably if we'll do like shift right once, we'll get the last result being 1. If we do it the second time, it will be 1 again. If we'll do the third time, it will be 1 again. So if we got our number being 0, 0, 0, we do not have anything else to move right. So probably we divided everything. So in this case, in our hash map for 7, we'll have something in the structure like bit 0, bit 1, bit 2, bit 3, but we'll not get to bit 3. We'll have like bit 2 only. So this will be count 1. This will be like count 1, and this will be count 1 because we have only one value. So for our hash map, if you start with 12, so we go with the next number, like 12 being the next one. And trying to add our set, we have like 12 here. We do have the value of 12. So first bit 0 will be 0, so we don't add anything, but for the sake of the example, I'll use plus 0. Bit 1 similar. Bit 2, it's 1 already, and we'll have like another value, bit 3, which will be 1. So we will add number by number in the end, and after we'll get all values. So once we finish creating our bit counting dictionary, bit count, we'll get all the values. We'll filter values which are greater or equal than k, and compute this formula like 2 power 0 plus 2 power 3, finding those values. So in our case it will be bit 0 and bit 1, the final solution. So we'll have we'll need these parts actually. Okay, so I think I am ready to write the code. I finally got what they want from us. I'm thinking, do I need to use the VS Code part? Yeah, let me try to write it in VS Code. I think that will be easier. So yeah, here I have the VS Code structure. Let me get this one. I'll define fastly my solution. So that will be the solution part. I have some unit tests here. So having the scenarios, let's add a couple of scenarios. So we have this vector. So we'll have a tuple of tuples in our case as the input. And 4. And the output will be 9. So this is our first scenario. Yeah, let's add a couple more. We have this scenario. And the output in this case will be 0. And let's add the last example as well. So we have K1 and output 15. Yeah, I don't know if that's a thing. The K-war, it's some math thing Not sure if that's a real thing or not, but that's an interesting problem though. It's pretty easy to solve, but we spend, I guess, more time trying to understand and figure it out. So yeah, we don't have just input, but we have how nums and k. So it will be nums and k and expected. So have solution, find k word, nums and k. So yeah, we defined our test cases. If we try to run now, this will not compile and will not work. So as an example, I may return 1, where usually what I'd like to use, I use a to-do. So I do a to-do part for this to compile. Yeah, it does. It compiles, but it's not useful for us. Next stage, what we need to identify is to define our hash map or our dictionary. But I'm thinking, do we need to use a hash map here or a vector where we can count indexes will be a more suitable solution? Because hash maps are quite expensive. So probably here, 2 power 31. Yeah, we do have quite big nums, 2 power 31. This means like we need a vector of 31 values or 32 values. Yeah, we will use not a, yeah, still it will be a dictionary where we'll be setting each index at in vector position. So we'll treat this as a hash map. So we'll create a mutable dictionary where bit counter, let's call it, where we'll define a vector of 0. We'll look at the constraints here when we see 2 power 31. This means like maximum what we can have here, it's 2 power 31. Probably 31 will be correct, but I'll use just 32 to be on the safe side here. Now what we'll need to identify, we'll need to populate this counter. Yeah, this I think it will be too much, but that part, checking that's correct. Yeah. So now let's populate the amount of ones. And I'm trying to see, because I do not know exactly how to do this. And one thing I would like to try, it's how to get the last bit of a number in Rust. I just want to count ones, count zeros. No, I don't like this. Oh, if we do and 1, so we shift by and. So Rust doesn't provide indexes into individual bits of an integer. You need to use bitwise operator instead. This will count from right least to most significant bits. So length will be a count 1 plus a count zeros. Yeah, that's a little bit too expensive in my opinion. Maybe I can do, or I don't know, maybe that's the way to do it. For n in 0 length, we do this shift by 1 and 1. Maybe we can try with the while loop. Yeah, I think of trying this with the while loop. So yeah, First thing, I'll need to create a test example. I would like to do some manipulation. So we'll have a test, right shift. Let's call it right shift. We'll be testing a couple of things. So let num, yeah, let me call it mutable num, will be 7. And let's do while while num greater than 0, greater or equal to 0. Probably that's the case. Let me create one. Let last bit will be num right shift 1 and 1. Print line, I would like to print this value. So last bit. As well, I would like to transform num into num shift right shift 1 value and print line num. Hopefully this will work. Yeah, so it looks like it cycles at 0. So probably we should stop. Probably we should stop before that. So last bit 1, last bit 1, last bit 0. But yeah, probably should do it here. Yeah, we kind of missed one. I was expecting to have. Yeah, maybe I should use a binary for it. Yeah, let's try this. Yeah, that will not work. This. So, yeah, actually, that's correct. 1, 2, and 1. Last bit is 0. Yeah. Wait a second. So we have last num being 1. So if we shift, yeah, just for me to understand. So let's print line. What happens if we shift one bit on the right? Let me call this as a test. So test 0. Okay, so if we move this one to the right, but it is already the last bit, so that's the tricky part. I mean, this strategy actually works because we can count ones, but we need to see if this is actually 1. So maybe we can loop until we get to 0 or 1, the last value. Because then if we shift it right, nothing will remain, and yeah, and then this will be 0. But if it's 0, also 0. So we cannot like figure it out. What's the last bit? That's the tricky part. I mean, how can we write it? Maybe we can do something like we do this. Maybe we can write it with a loop. So we can try something like this with loop. If num will be either 1 or 0, then this will be our end, so we'll break. As well, inside we'll be able to find out what's the last bit, like being 0 or 1. If num equal 1, then in this case we can increment. Yeah, so I guess the algorithm to count number of bits which are set or not, we can use something like this. So we can use an index where bit, probably bit will be the most accurate name for it. So we'll have like bit. Then we can go inside, so we'll start with our num. So we have our loop here. So we do let bit value will be num shift 1 and 1. We'll be printing out, in this case, what bit we are talking. So bit and the value of the bit. So here we'll have like a bit and bit value. So once we did that, we need to go and shift right. Yeah, probably that would be the correct form. So num will be changed. And then we have this part. So in this case, we'll have like print line, last bit. Okay. Yeah, here we'll have bit plus 1. So here we have a bit number, and value will be one of the two. So if num 1, then we do this. So it will be bit and 1. Else the second part. So I assume now I'll have all my bits. And yeah, we should not forget to break our loop because we finished. So let's try to run this small example. So bit 0 it's 1, bit 1 it's 1, and bit 2 it's 1. So looks like this algorithm works. Yeah, probably I should make it a little bit more. Yeah, so this is correct. Yeah, let's try a different value. So let's try, I don't know, maybe 15, where all bits will be set. Let's try like 9. So 9, it's in reversed order, 1, 1, 0, and 1. So it does work. It does work. So now we have our algorithm. We have now our bit counter. What we should do, it's for each num, we should apply this logic. So we'll have our bit part. We'll start with our bit, then we have our for loop. but we are interested only in the set bits, not the zeros, so we'll not care about zeros. Yeah, maybe I should do like a clone of num_c. Yeah, maybe like that. Or we shouldn't care much, I don't know. Let's use mutable here. Yeah, we don't need the printed part. What we need to do here though will be like bit counter of bit plus equal 1. But no, not like that. We'll need to check first. If bit value it's 1, then we increase it. We do this, then if we have this, we do as well this part. Yeah, it's a little bit ugly code. I feel like there should be a better way to do it. But yeah, let's test our first example. Bit counter. Yeah, we'll try to optimize it somehow. I do not know yet how to do it, but let's try. We'll try to optimize it. So yeah, let's right shift. Actually, I do not need this test anymore. So we can try to run our tests, and I'm expecting yeah, not yet implemented. So I'm expected to have, I'm not sure if that worked though. Because for first example, we should have a little bit different vector. I think we should have like for bit 0, one moment. We should have like for bit 0, 0, 1, 2. Okay, so 4, 2. We don't have 6, or do we? 1, 2, 1, 2, 3, 4, 5. Or do I miss something? I think I missed to add some values. So how many values are here? 6. Do I have 6 values? Yes, I do. There shouldn't be ever 6 pluses. So something, probably it's double counted somewhere. Yeah, so I feel like this doesn't work. It's a little bit not correct. I mean, yeah, we can do this way, or we can do the old way. Probably right shifting, it's a little bit too much. Yeah, let's try to go the old way, while num greater than 0. So we do let bit will be, yeah, still will need this. Okay, it still will be like bit value. The old ways, I would do it like num divided num modulo 2. So this could be either 0 or 1 in our case. And this will give us the value, and we'll do bit plus equal 1. But before that, we'll do bit counter. Yeah, still we'll need that check. If bit, Hi, I was trying to solve, but I can't solve the question. Can you please suggest something? Oh, yeah, kind of I figured out the question. So probably you're not from the beginning, but let me try to get back to my drawing board. Because I also spent some time trying to understand what in the world do they want from us. And I think I figured it out. So first stage, what I did, I transformed these numbers like 7, 12, 9, 18, 9, 15 into binary form. So this is the first thing I did. So I have it here. The second thing, I took this example and tried to understand what do they mean by bit 0 is set at num0, num2, num4, and num5. So I have these bits like position 0. So I try to understand what does it mean for bit 0 to be set. And actually, if you transform it in the binary form, where we have ones, this will mean that this is a set bit. This is set. So if we go with our vector, this will be like position 0 of the vector, 1, 2, 3, 4, and 5. So when they tell like bit 0 is set at num0, so yeah, this is at num0 is set. Nums2, yeah, here is also set. Nums4, so yeah, indeed, nums4 is also set, so this one. And nums5, here is also set. So this is what they mention where this bit is set. So if we count the amount of bits for the bit 0, we have how many bits set? 1, 2, 3, 4. So we have like 4 bits set here. Does it make sense? Not about this question, but about other ones. Yeah, we can get into other ones as well. Yeah, I would like to finish with this one to provide a solution. And then move on to the others. But for sure, yeah, usually I go with every problem. I try to understand it myself and then come up with an algorithm. And then if this works, then everything good. So yeah, for now I'm coding this stuff. Okay, so if bit value, it's 1. Yeah, we don't need the brackets. We'll need to increment it. So bit counter plus equal bit counter at position bit. Yeah, maybe call it bit index. Yeah, that would be cleaner, I think. We'll increment this with the 1. Then we do this part. Then we'll need to make sure that we will decrease our num by 2. So that's another way on how we can count our bits. 4, 2, 3, 5. Yeah, that's the answer I wanted. So I have this structure. I have this structure. I have my bits. I counted everything. So probably here, what I can do, I can extract this into a function. So let me extract this into count bits, probably. Count bits. So what don't you like? Yeah, bit counter should be a mutable reference in this case. Cannot be dereference. Nor do we need to do that. So I've extracted this into a separate function for this to be cleaner. Now the algorithm looks a little bit cleaner. So yeah, this needs to be a mutable reference set inside. So yeah, first stage, we identified our, we counted our bits. Next stage, we'll need to filter out all values which are greater or equal to 1. So you can do that with an iterator. So we can do something like bit counter iterator. Yeah, the interesting part here is that we'll need to enumerate because we need the values to do our computations. Then we'll do the next stage, we'll do a filter. So now here we'll have the first stage will be our index, but we don't care for the index, we care for the value, for the count. So we'll need to filter out the count greater or equal to k, the provided k. Next stage, we'll need to fold the result. So in order to fold, we'll use, because this is a sum, so the initial value will be a 0. Then we'll have a mutable accumulator. Then inside our value, we'll have the index, because this is what we need. We don't care for the value now itself. I feel like I messed up a little bit here. And the results should be correct. So we have k, I32, but count its reference. Okay, whatever. So we can dereference here, add a value here. And here, the trick is to do accumulator plus equal to I power. I think that's the command. Or it's pow. Kind of forgot how in Rust to do power. So it's I think it's I32 pow. Yeah, okay, so like that. So yeah, clear. So it's the value 2 pow and index, because that's our index power, but index in our case it's usize, so we'll need to transform it to an I32, and we need to return our accumulator. And something is wrong, can't call method power on ambiguous numeric type. So what's ambiguous? Yeah, okay, so let's do it like this. Expected, okay, let it be U32, I don't mind. Do we need here num to be mutable? No, we don't. So I feel like that should be it. So let's run our test. Yeah, indeed, the tests are correct. So we have our solution. So it took a little bit longer than I intended. But what can we do? We spent some time understanding the problem. We spent some time cooking the solution. Yeah, cases are correct. Let's submit. Cool. So we have actually a pretty fast solution. Yeah, let's check other. Oh, a spread number with bits in position 0, 9, the rest 0 to U64 with those bits in every 7th position. Compress. Yeah, this guy, it's deep into bits. I'm not sure I will ever understand what does he do here. In my case, it's more straightforward. I count something, I sum, I have a dictionary. And it looks like it's faster than his. So I'm not sure what's the point of all this. Yeah, maybe it's a little bit more code. I don't know. Yeah, for now it's good. Yeah, we have another problem. Divide the array into equal parts. Knight Emperor, are you still here? So do I need to explain more in details what this is about? How many did I solve? I solved a couple hundreds, couple hundred problems. So let's check. So if I refresh, should be around 207, I think. 207 problems, out of which 107 are easy, 83 are medium, and 17 are hard problems. So yeah, but I've just started actually. It's not like I'm deeply advanced into this topic. When I'll have like 500s or so, probably I'll consider this as an achievement. But for now, just grinding. So yeah, some problems are easy in a form, but you still need to spend time to come up with the right solution, to figure it out. And they are not equal in solutions. So some you'll need to spend literally an hour to understand what's going on. Others, like this one, I think I looked through this one and I thought I didn't run to check if that works or not. But I forgot what's the... Okay, so you're given an integer array nums consisting of 2 power n integers. You need to divide nums into n pairs such that each element belongs to exactly one pair. The elements present in a pair are equal. Return true if nums can be divided into n pairs, otherwise return false. Yeah, this is actually a property of XOR operator. Where are you from? I am from Republic of Moldova, so it's close to Ukraine. Let me show you guys. Not sure if you ever... Yes, probably here. Of a map. So I'm popularizing this small country. So if you see at the map, so Romania. Yeah, I'm not sure that's a good map. Maybe I should pick something easier. Yeah, so so this one would be more appropriate. So it's Ukraine, where the war is, and then we're neighboring Moldova, and then Romania, Slovakia, Poland. Whoa, I'm from Ukraine. Nice. Oh, so you're neighbors. So cool. Yeah, unfortunate times now. It's short Kiev. Not sure I know the region, but I work with a lot of guys from Ukraine. So I do monitor the situation, which is unfortunate what's going on now there. But hope it will finish soon. So I guess more patience, guys. I'm from India. India. Yeah. Yeah, cool. I've looked at the stats on my YouTube channel, and looks like more people from India are watching. So looks like you guys have an interest into this problem solving and algorithms. So it's something when you're in your blood, like chess, counting a lot. So that's really cool. Yeah, so about this problem, so there is a cool property of XOR where you, when you XOR a number with itself, you get 0, so it nullifies it. So in this case, we can easily do this problem by XORing everything using a fold. So XOR operator will be this in Rust. So we need to just count if the end result is something or it's 0. If it's 0, then we are good. This means that we can create a pair. If not, if we'll get... Do you know Lebanon? As a country, yes, but I never went to. Yeah, we learned a lot of counters. So yeah, let's check this solution first, but I think this will work right away. Yeah, indeed it worked. So this is a cool trick with XOR. You can XOR a whole array and it will nullify all the pairs. So if you want to find if the pairs are equal, then everything good. So this should be a pretty straightforward solution. Wrong answer. That's interesting. Why? Yeah, let's try to check why do we have this wrong answer, because I was not expecting that. Yeah, let's use this test case. What's the trouble here? Yeah, I just wanna add, okay, so we have troubles now. Probably I should create another example. Okay, so how is this stuff is called? Description, divide the array into equal parts. So go new lib divide array into equal parts. Is it Python? No, that's a Rust language. So it's a low-level language, not Python. Okay, so probably I'll do this and then this, and let me zoom it for you guys to see it properly. So I have another example. Let me try to add this solution. Not solution, but struct solution. So we have our result here, and we'll need to add a couple of test cases, but I don't need all the test cases. I need only one. Divide array. So let's add the values. Yeah, probably you'll not see it, so let me close this part and scroll it up a little bit. Yeah, so let value. Let me copy this. So we have all the values here. We'll have the values. Yeah, this should be a vec. And solution, it's expected to be true if I'm not mistaken. Okay, so output true, but expected to be false. So we copied that test. Let's run it. So true equal false. Yeah, and in order to debug it, result, I'll have like a result having value here. So I'll have like a print line. I would like to see what the result is. So we'll use the debugger. Yeah, we don't need this, and we don't need this. So we have 0. Wait a second, I think I mistakenly did. Because we may have 0, but cause. Yeah, did they specify? Okay, so we have nums length to power n. 1, 2, 3, 4. Yeah, let me add a couple of. Do you have a job related to this or just learning? No, I'm a backend engineer, but I do not have any relation uh, to bit manipulation. So just learning um, to just improve my skills. I never use at work this kind of stuff with the XOR. So this is more like low level. But you know how it is. Maybe sometimes you don't use because you don't know. So once I'll know it, maybe I'll use it at work. I'll find the places to include this part. But I'm not sure I understand what's the problem here, to be honest. Okay, so let me close this. I'll need this to be once again. Probably I'll do it a little bit differently. Okay, so it works. Let me do my scenarios. Where I'll have this and I'll have false or true. Next stage I'll do solution, divide array, input. Okay. Let me add all the scenarios. If I'm going too fast, guys, you can tell that I should try to slow down a little bit. Because I definitely will try to do that. Okay, so this I'm expecting to be true. The other example here, 1, 2, 3, 4, expected to be false. Yeah, this is not the way I wanted it. False, but I'll add the last one. Hello, hello. Oh, you have a long name. So, sorry, sorry, it's difficult to read it. Oh, which company? So it's called AW Core. So let me type you. So I use another device. AW Core. So that would be the company name. Um, but it's like a subsidiary because we are working for another company. So we pretty much are contractors. So this AW Core, it's more like a remote company where where they handle all the HR stuff, the payments and everything. But we are just engineers trying we are working for a different company, and unfortunately I cannot tell because I've signed an NDA. But the idea is we're working in the clinical trials, so clinical industry, clinical trials industry. We're coping with big pharma companies, so very big clients. Are you from America? Please respond to my call. No, I'm not from America. Sorry, I just tried to read your name. So, Migada. Uh, yeah, I'm from Republic of Moldova, so it's an Eastern European country. I think I've answered this question a couple of minutes before, and somehow I dropped my. Is it learning? What exactly? Sorry, I kind of need to zoom this a little bit. What to learn? Sorry, I'm a bit confused. What to learn in 3 months? Vamsi. Okay, so it's Vamsi. I'm from India. Yeah, there was another guy like Knight Emperor. So he was also from India. So maybe so cool that you joined the stream. So it's really, really, really cool. Data structures. Uh, Data structures and algorithms in 3 months. I mean, you can have like a pretty good progress. It depends on what do you mean by 3 months. So if you tell like 8 hours a day where you'll be coding algorithms and stuff, so 3 months will be like 160, 170 hours a month, 340, 520. So it's 500 hours. It's pretty good result, but if you push it hard. But data structures are tough, and it's a ton of work you'll need to do. So I'd recommend the book. Let me try to find it. I think I have it. So it's this one. It's called Introduction to Algorithms and Data Structures. So it's it's a pretty thick one, to be honest. In which company? I did write a little bit above in the comments. Vamsi. It's called AW Core. So that's the company I'm working for. So yeah, it's close to how many pages? Yeah, 1,200 pages, something like that. So in 3 months, I feel like you'll have like a pretty good progress with this if you start with data structures. But it's big, literally. I mean, it's a couple of years of work. So you go, you learn something, you get back. So it's like chess. I know India, it's very popular for chess. So it depends on the level which you want to get, but to be like an IM, international master or something, 500 hours is not enough. You'll need to put like 5,000. But if you want to be comfortable with writing like small algorithms here and there, I feel like definitely it will be a good progress in 3 months. So you'll have a grasp of the main most important ones. So yeah, the company is called AW Core. So it's an subsidiary, and we are contractors for a big pharma company. But I cannot disclose the exact company's name. I signed an NDA, unfortunately. So in our contract, it's mentioned that we are not allowed to disclose the company name. Yeah, let me get the last test case. I would like to finish with this one because we are not very productive today, to be honest, guys. So it's expected to be false, but we answered true. I have a knowledge of Java and basic data structures. Can I get a job? Definitely you can. I mean, it's just passing through interviews. So you try to apply for positions. Java positions are always in demand. So it depends on your experience level. If you don't have any experience, you'll try a junior position. If you have experience, then stack and queues and linked lists. yeah, these are the basic ones. So you start with those. Trees, yeah. Actually, when you talk about trees, there are so many trees. I mean, I'll show again this book. When first I thought there were a couple like binary trees. What else? So yeah, actually, at some point in time, I had only this understanding of trees, like binary trees. But there are tons, like B trees, which are not binary trees, red trees, um, a ton of other like tries even. This is a different data structure. Also has a tree structure, uh, and tons of yeah, I mean, yeah, there are three like fish. Yeah, when you tell about like fish in the ocean, with data structure is the same. So there are so many different kind of fishes or the fish. Okay, let me try to understand what's wrong with this solution because I would like to go to another problem. Because here it's something not right. Uh, it's 0. Can a freshener get remote jobs? I would highly not advise you to get a remote job when you started. I started my career in 2012, so it will be like 11 years or so. So for the first 5 years, I worked at an office job. It was not paid much from one perspective, but from the other, I learned a ton. So if you manage to find an office job where there are like people where you can learn from, this will be gold for you. Because if you go remote, you'll have issues with discipline. So a remote job seems on paper that's a cool thing, but it's extremely tough when you do it for many years. You get into some psychological issues, solitude, because you work from home most of the time. So first of all, you'll need an office. Yeah, as you can see here, I have my own office at home where I can close the door and concentrate. So it's not easy. Is LeetCode really good? I mean, I like it. It challenges my understanding of algorithms and knowledge. I used to solve problems on another site called Code Wars. I feel like LeetCode it's a little bit too difficult for beginners. The other side I'll show you. It's called Code Wars. And I saw like also a couple hundred. Yeah, let me connect. Authorize. So yeah, I've sold like a couple of hundred of JavaScript. Completed katas. No, I think that's not the right number. I didn't solve like 1,000, or maybe I sold 1,000. No, I don't think like it's 1,000. Yeah, I solved like 300 problems here on this side, but this is way easier. At least it used to be easier. So you start, so you have like the concept of like queues. It's from karate, if you know. I'm from country, doesn't support technology, and literally lost if I continue, or from country. You mean you're from countryside? You live in a village or something like that? Sorry, I didn't really get. So yeah, let me finish my thought first. So I would recommend beginners or absolute beginners this site. It's easier. Here, I mean, 8 queues and 7 queues are literally easy problems. Like 5Q, it gets more complicated. But I started here. But LeetCode is more complex, and they are focused more on data structures and algorithms, like a deeper understanding. So yeah, actually it's expected to be false. Oh my god, what I'm doing. So yeah, so force, if you live in a village, I mean, also in my country, live in a village. Uh, if you want to work remotely, you kind of need a good connection, so to be reliable, to be disciplined. And when you start, when you're young, this is not easy stuff, to be honest. Discipline, it's tough job to have. So yeah, as a software engineer, remotely, you'll need to push a lot of hours, because you work mainly not for amount of hours, but for result. I mean, you can put like 10 hours, report like 10 hours, but if the output will not match this amount of work, they will not keep you for long. How to increase productivity? Yeah, it's a tough question, but from my experience, it's through discipline. Some days you'll feel very bad, I mean, like not doing much. But you'll need to have like a base level where you know that you'll not go under, and try to increase this base level little by little. So consistency is way more important than bursts of productivity. And I also have this issue. I mean, it depends on your personality, because sometimes I'm a god at engineering. I mean, literally, you can do solution after solution, and I look like a genius. But other times, I'm on the verge of being fired. Like, I literally am blank, cannot do anything. I cannot motivate myself to do anything. So this is why remotely, I mean, it's more difficult. When you are in an office where everyone is working, you go to lunch together, you are around people, you motivate each other. But at home, it's difficult to work alone. And for the last 6 years, I'm more working remotely alone, and I have some problems sometimes with this, with the productivity part. They're not always easy. So for beginners, I definitely recommend to at least have a base level of productivity where you can reliably produce stuff. And you'll develop that in an office. Okay, so what do we have here? So let's run this stuff. It's 0. Okay, so it's 0, so it's false. But how in the world this should be true? Because I don't want to kind of compare. Yeah, let me try to do this. Maybe it's a broken example, which should be very unfortunate. Yeah, so this two we get out. So playing puzzles now. So 12 and 12 out. 3 out. What else do we have? Like 19 out. I saw some 9s, so this 9 and this 9 out. 11s out. What else do we have? Okay, so yeah, let's see pass. I would like to find more pass. So 16s. I see a couple. Okay, so yeah, let's check this. Do you know any other language? Yes, at work I work in TypeScript or JavaScript, let's put it this way. So Node.js. I also write Python from time to time. I used to work to do PHP for 5 or 6 years. So yeah, and definitely at university we learn C. I did not have like a production experience for C, but still can write some code there. C++, but yeah, didn't write a lot of C++. And Rust, yeah, mainly Rust now. So spending my days trying to figure it out, where is the problem. So 2020. Like I see a couple of flaws. Let me clean them up once. So yeah, a couple of language I know. But it's not really important. I mean, you could know 100 languages. That this doesn't tell anything. It's important to know one, but really, really good. I mean, at a high level. Then you'll be. Yeah, any course it's a good thing to do. AWS, anything, Node.js, language courses. Any course, it's a good thing to do. I'm not sure if I'll do personally AWS courses if I want to be a programmer. If you plan to be on cloud side, you definitely will need to. So you plan to be a cloud engineer. If you intend more on writing code, then if you use Java, then there are very good Java certifications which you can try to shoot for. So that I would recommend. This will improve your skills, also your confidence, and also your credibility. Yeah, what I'm doing now, I mean, I'm spending time trying to figure out the test case. Yeah, I do not see 11 though. Yeah, that's an interesting case. Okay, I have a couple of 2s. I have a couple of 2s. So another couple of 2s. What else? 14, I see 14. Do we have 14? Yes, we do. Almost there, almost there. 16, yeah, we do have complement 16. Yeah, looks like they do not want this to be solved with the XOR, if I have a feeling. So 3. Yeah, I'll have a couple more 9s. 2012. So 11 years ago. Yeah, why did they do this to me? I don't know. I mean, that's the solution, but yeah, they want to go this way, which XOR operation would be faster, but I don't know. I think they added it. Yeah. Exactly. I have the same trouble. So to work, can you explain me this? How to solve this only XOR? I mean, yeah, that's sad. I mean, yeah, they kind of uh, we're asking a question. We're asking a lot of questions. No troubles, guys. I mean, I'm here to have a stream. So during a stream, the streamer is supposed to interact with the viewers. So, so, but actually, I'm glad to solve. Yeah, I'm a little bit sad about this problem because it looks like they want us to solve it not using this, and this is a little bit unfortunate. Because I can solve it. It's not an issue. I just need to count the number of pairs. But it's a little bit sad that it's not like a bit manipulation problem. I wanted a bit manipulation problem. But yeah, anyway, let's try to fastly solve this using another approach. So how can we solve this? So what we'll need to do is to count the numbers as well as in previous problem. And we'll for each count, what we'll need to do is check if it's divisible by 2 or not. If at least one is not divisible by 2, then we return false, which it's boring, but this is how they want us to. I can write, and now I'm not sure if I'll manage to solve it in C, because I'll need to recall the structure, but I can write in a way which will be easier for you to understand. Or I can explain first what I'm trying to do. I'm okay with Java. Unfortunately, I'm not. Maybe JavaScript, guys. Here, what I'm doing, I'm declaring a vector or an array. I don't recall in C how it's an array. I think it's like this or something like that. But it's not A, but just A or int A. That will be an array of A. I forgot the syntaxes in C. I'll need to recall the syntaxes. But what I'm trying to do, it's frequency of numbers. So how can I know how many numbers will be there? So yeah, I don't need discussions. Length is 2 power n, and n is less or equal than 500. So actually we know that the values will be in interval 1 and 500. So what I can do to start, okay, JavaScript. So JavaScript is okay for you. Yeah, let's try JavaScript. Divide array nums. So I guess first stage what we'll try to do is to create an array of frequencies, or the other way around is to do a map. So let map will be like yeah, but not even like this. So let me try to flex a little bit. So we'll have a fold. In JavaScript, fold works a little bit differently. So we'll have like accumulator and item. What else will I need? Nothing here, and I have a new map. So map, it's a hash map as we do in Rust. And this stuff I can call it frequencies. Yeah. Any questions so far? Yeah, so yeah, let's count those frequencies. So we can do like if accumulator get, or let's do like this. Yeah, in Rust you write it a little bit cleaner, but here it's fine as well. If accumulator dot get item, if you have it, then we'll do, if we don't have it, then we'll do accumulator dot get dot insert item and 0 where it's set, something like that. We'll see. We'll see if this compiles or not. So we'll need to return the accumulator. But what I'm trying to do is to add the frequencies. So if it's not there, then we'll insert with 0 and then accumulator.get item, and we'll plus it, because we need to increase the number. So we can give it a console log here for the frequency to see how it is, and let's return true for now. I just want to debug and see if this will compile. Yeah, it's not fold, it's called reduce. Sorry. Yeah, it's a little bit tough to switch your mind from one language to, and it's not set, because it's set, it's not insert. Okay, like that. Wait, what am I doing wrong? So accumulator get, how to increase communication skills. Reading a ton, trying to present, maybe an YouTube channel can help. So doing content, doing presentations, learning to speak better. English is not my native language, and I learn it. So try to learn. It's tough to speak English correctly, I mean without accent. So what's the trouble here? Accumulator get. Yeah, let's do the following. I don't know. Let val be accumulator get item. Okay, whatever. If we don't have value, we do set it. If we have value, then we do actually we can do it like 1, and then here else we'll do accumulator set item val plus equal 1. So yeah, that would be a more JavaScript way on writing this code, and this needs to be a const. Yeah, I'm just trying to val plus 1 doesn't work. Why doesn't this work? Yeah, let's try this. I'm pretty sure this should work. Oh, yeah, something like that. Okay, wherever. Okay, so you can see here, it's we have our map and the results. So now we have our counts, like 1 1 2 1 3 1 4 1. So what we can do now, we'll need to make sure that all, so we can have like frequencies, I think it's called entries or values. Yeah, probably we can use values. And this we can do like not some but all. Yeah, that would be in Rust, sorry. I think it's every called. Maybe every. And here we'll pass our item. So we'll need like item modulo 2 equal 0. Let result. Yeah, or actually we can return this. Yeah, it's a bit tough when you write in two different languages, but okay, so it's not values. It's not a function. JavaScript, all. Not all, every. Some, I mean, but it's not some that I want. Not some, but all. Do we have all? All, no, not callback. How it's called that stuff? Last from is array. Reverse shift slice sum. I don't need some, I need all of them. Is it every? I literally forgot the name of that. It's every. I mean, oh my god, what I'm doing. So it's every. So yeah. So we have our threshold, array, every, behold, blah blah blah. So I was correct, but not sure if I am completely correct here. So where's our problem? So values. But looks like this is not an iterator. That's the problem. So we'll need to do array from, and then create an iterator from these values, and then apply this function. So that should do the trick. Okay, looks like first it's false. Why? Yeah, let's do a console log here. Our frequency. Not sure I do it. So 3 it's 1, 2 it's 1. Yeah, looks like our frequency counter doesn't work. Okay, so let's check again. Maybe after a day of work, my mind it's going blank. Oh my god. Okay, so let's rewrite this. If accumulator has item, then if we do not have the item, then we'll do accumulator set item 0. So it's our counter. Then here we'll do let value will be accumulator get item value plus equal 1 accumulator set item value. So that would be our setting part. So this will be the frequency in JavaScript. So now should be correct, hopefully. Okay, so we have this. So now it's correct. Probably we have some troubles with this. Yeah, I would like to console log this part. I do it. Good. 2 and 4. Okay, so every item. Yeah, this is when you write too much JavaScript, too much Rust. because I need to return it. Okay, so that would do it. Yeah, but I don't like this. I don't like this language. I use it too much to like. So I'll shift back to my Rust code, because I'm in Rust mood to solve Rust code problems. Okay. Yeah, we solved a couple, but not many today, so probably we'll need to shift gears and try to go a little bit faster. I think I solved like 2 problems today, which is pretty sad from one perspective. Okay, let's check again. Single number. Given a non-empty array of integers nums, every element appears twice except for one. Yeah, this one, I hope it will work with the XOR operation. So we'll do like iterator fold, and we'll do one. We'll do mutable accumulator and item, and here we'll have yeah, it's similar as in JavaScript, but a little bit different from one perspective. So yeah, we'll need to XOR this and return accumulator, and we will have our item. So I hope this will work. Output is 0. What am I doing wrong? Oh, so it's not 1, it's 0, I think. Yeah, that's a little bit faster. So let's submit and hope they did not add like a weird one. Yeah, okay, so that was faster. Next one. You're given a positive integer n. Let even denote the number of even indices in the binary representation of n, 0 indexed with value 1. Let even denote the number of even indices in the binary representation of n. Zero indexed with value 1. What? I don't really understand. Let odd denote the number of odd indices in the binary representation of n, 0 indexed value 1. Return an integer array where answer even or odd. So 17. 17 is this number. It contains 1 on the 0 and 4 indices. There are 2 even and 0 odd indices. Oh, so even will be like yeah, that's kind of a shifting problem. That's like a shifting problem, like the previous ones. Or division by 2. I still don't get it. Why should I use 1 over the other? But the simplest way to solve this will be like we added this once. While n is greater than 0. If it's 0, yeah, it's fine. We can exit. So we'll do like, yeah, we'll need a counter. I didn't understand. What exactly? The previous problem or this one? Yeah, I guess if it's for this problem, it's quite easy to understand. It's also not very difficult. So yeah, let me use a new canvas. So let's imagine if for this problem. So imagine we have 17. So yeah, let me example 2. So let's pick example 2, yeah, and 2. Yeah, it's quite straightforward. So for example 2, we have like number 2. Number 2 in binary form, it will be like 1 0. If you go, this would be 0 and 1, the position 0 and position 1. But I think they do not count 0 index with value 1. Even to know the number of even indices in the binary representation of an 0 indexed with value 1. If I understood correctly, even and odd. Wait, I think they messed up a little bit, or not. So anyway, so maybe I should go this way, 0 and 1. So this will be an odd index, but this will be an even index. So we need to return back the amount of ones in the even positions. So it's even first or is the second? I'm confused a little bit. So even first, odd second. So the result will be like 1 even and 0 odd. So that would be the result. If I looks like I've messed up. It's vice versa. So yeah. Not really, because you will not use like 4 of them. But it doesn't really matter because we count only once. So probably they go the other way around. I'm not sure why they do this. So it's 1. If you go like 2 being 1 0, this will be like 0 and this will be like 1. So probably they count it this way. So we'll have like even. Yeah, you kind of confused me as well. I'm not sure I understood it myself. Yeah, let's go once again. Yeah, so let's go with the example 17 because I think it has more values and it's easier to understand. So have this example. 17 will be 1 0 0 0 and 1. So if we start from the left side or from the right side, so we'll have the following indices like 0 1 2 3 and 4. Yeah, probably I should use 2 colors. Like 1, I'll use this. 2, I'll use this. 3, I'll use this. And 4, I'll use this. So this will be even. And this will be odd, yeah? Or odd number. Odd and odd. So is it even first? Or wait a second, then no, oh my god, what I'm talking. So my English is flawless as usual. So this will be even and even, and the other way around for this too, this will be like odd. So now we count ones. So we see in even position how many ones do we have? This, this, and this, and this, and this. So in even position we have 1 here. So this one. So let me use like a red color. And we have here no and here 1. So the result expected to be even odd. And then it will be like 2, because we have 2 2s and 0 odds. Oh, okay. So that would be the first example. So if you go with the second, like 2, 2 being 1 0, then we have 0 1, so this will be even, this will be odd. So even will be 0. But wait a second, why odd is 1 in this case? Because that's not correct. Yeah, so they do count it from 1 then. Yeah, I do speak Romanian, so Romanian and Russian. So 2 languages, we do speak Russian and Romanian. Let even denote the number of even indices in the binary representation of n, 0 indexed with value 1. Let odd denote the number of odd indices in the binary representation of n, 0 indexed with value 1. So we start at 0. How do they get 1 here? I don't understand where this 1 come from. Because we don't have in odd position a 1. Yeah, I also do not get it. Yeah, I mean, but I do not get how do they got this value. It contains 1 on the first index. So they start at, man, what did it's not, that's confusing at, so how do they start counting? Once again, I still don't understand. Oh my god, sorry. I finally got it. So yeah, everything is clear. So they count the binary representation, but they do not go from left to right, but from right to left. So it's vice versa. So this, instead of this stuff, will be starting like 0, 1, 2, 3, and 4. So the result will be the same, but this will solve the second issue, this one. Because now we have the value of 2 in binary being 1, 0. So we have 2 indices now. So this will be like 0 and 1. So everything is cool. So now we have like odd part and we have like even part. So odd will be 0 and even will be 1. So now it's clear. Not really. I would schedule it, but usually I schedule 2-3 streams a week. So during the weekend, tomorrow or after tomorrow, for sure I have another stream. Either tomorrow or on Sunday I'll have one around same time, so around 8 around this time, to be honest. It's 8 it's actually 10 in the evening here, but I can see. Okay, yeah, finally we understood our so-called problem, which is similar with the one which we solved already. I think it's the first one where we counted the frequency, so it's exactly the same problem. What even can do? It's something on those lines. Yeah, okay. So I'm thinking where to store the values, but I guess the easiest way is to have like two counters. even. And now we do our operation. Probably we'll divide array. Try to find the previous problem which we solved. Largest divisible subset. No, that's the problem of today. Yeah, let's get back to our previous code. We'll reuse a bit. Yeah, too many dots. Let's try this. So I would like to reuse this function of counting bits. Reusability, how we call it. Good night, guys. Yeah, good night. I think I'll solve this one and I'll finish for the day as well. How did I learn English? Yeah, I do train a couple of times a week. I have an instructor where I train my speaking skills, and I retrain my facial muscles to have the right intonation in English. But I've learned by reading a ton, as well listening. For pretty much I moved to English content like movies, TV shows, reading, trying to listen to radio, so like try to listen to British radio during the day. Okay, so let's count this, but so this will be the position part. I'm fine with the position part. Yeah, let me check the constraints. Description, so constraints are small. 512. Okay, wherever. Let's use like 10. I think 2 power 10 should be way than enough. Will be like count bits, back to 0, 10. I got lazy a little bit, but so we'll do count bits. Do we need it to be mutable though? Yeah, it does need to be mutable. Good night. Okay, so yeah, good night. I'll finish this problem and I'll finish the stream as well. So yeah, let's count these bits. And then go for odd even position. Probably I should go with partition or something. Maybe I should go with partition. Yeah, that's a really cool stuff. So there is a function in Rust called partition. So yeah, exactly what I need. I mean, they made it for me. Into partition. No, not here. Not here. I want to do it. So here, partition. It's a little bit of an overkill though, but fine, I guess. So yeah, we'll have our counting bits. Yeah, here we'll need to send a mutable reference, otherwise it will not work. So yeah, let's count our bits. Count bits. But it's not this that I need. I need the iterator part, and I need to enumerate. And here, instead of an, I'll have like index. and an. Do I need an? I don't know. I don't need an for now. This will be like index. So have partition. Okay. So I have all the odd, not odd stuff. Yeah, this is such an overkill. I mean, we don't need to do that. Yeah, but for the sake of learning a new thing like partition, I will leave it for now. So yeah, I guess let's do this. Even will be even iterator that map. Yeah, maybe here. Yeah, wait a second. Maybe here. Can I use a map here? No, I don't think. It's possible because I need to map it. Something like this and then we'll need to sum it to 932. We'll need to do similar stuff for odd. Wait a second, I need to return this and sum again. 532 and return a back of what did we decide to return? Even and odd. So yeah, that should do the trick. Maybe I have some typos and things to reconfigure. Count bits. What? I'm not sure I understood. What's the trouble? Yeah, let me try again. Yeah, let me copy this. Divide array. Okay, so we have a couple of problems. So first we need this. Then probably we need to dereference this. And counting bits part. Okay, so let me add one simple example. Solution, even odd bits, 15, wherever. Set equal 17. Let's check 17. So assert equal result back to 0. I think that's the result. Count bits has type vec integer. Call expression requires function. Oh, yeah, I have a count bits and count bits again. So let's call it bit counter. I think that's the trouble. Okay, so here it will be like bit counter. And now let's run again. Okay, so looks like this should be it. It's not valid value of type integer. Oh, what? Mute? I don't understand what this error is about. Yeah, let me check the second example. Maybe there is yeah, I don't need this. Yeah, let me check this example. So what happens when we put 2 here? 0 and 1. Oh my god, what's going on? So it does work here, but doesn't work there. So why? Case 1. So invalid test case. Like there is something there which oh, looks like I pasted something here by accident. Yeah, I've pasted by accident something in that tab. Yeah, because kind of I need to. Yeah, let's try that. Okay, so this worked. Yeah, so probably it will work. So let me push it. Yeah, okay, so in the end we barely made it. So we solved a couple of problems. How many? Like 3 problems. I mean, yeah, 3 problems in 2 hours with a lot of speaking and some learning as well. So probably it's not that bad. Yeah, yeah, let's wrap it up. So thank you for everyone joining, leaving comments and feedback, and for the discussions. It was a pleasant discussion, guys. So have a nice day, a nice evening. So waiting you all for the next streams. Yeah, bye bye.